Okay, so we're going to do the linear programming today, taking word problems and then making those inequalities and that one equation that you did for last night's homework. You've got to be able to translate the word problems into those inequalities and equation. So I kept the words kind of small so that I could put them all on one screen. But anyway, here we go. Jean and Wesley are making wind chimes and birdhouses in their craft shop. Each wind chime requires 3 hours of work from Jean and 1 hour of work from Wesley. Each birdhouse requires 4 hours of work from Jean and 2 hours of work from Wesley. Jean cannot work more than 48 hours a week. Wesley cannot work more than 20 hours per week. If each wind chime sells for $12 and each birdhouse sells for $20, how many of each item should they make to maximize their revenue? In all of the problems today, we're going to be maximizing. And in last night, sometimes you maximize and sometimes you minimize. We're going to keep it a little easier for the word problems. We're just going to maximize. Okay? Um, and in all the problems for today, we're going to be producing something. We're just going to do one style of linear programming word problems so we can kind of get those down. So in all the problems for today, we're going to be producing something. In this problem, what are we producing? Birdhouses and wind chimes. Those will be our two variables, x and y. We're not going to have more than two variables in these problems. So since wind chime is mentioned first, I'm going to write wind chime first. And call that my x. You can choose one for x, one for y, doesn't matter which one. And my birdhouse, I'm going to call my y variable. Okay, first thing, figure out your x and y variables. Okay, now we'll go with the easy equation, the objective equation, the profit, where we're going to try to find our minimum and our maximum. So usually the profit is down at the end of the problem. So here it says, if each wind chime sells for $12 and each birdhouse sells for 20, how many items should they make to maximize their revenue? That tells me my profit or my revenue formula here. So I'll call it P for profit. You can call it whatever you want. And $12 times every wind chime I make plus $20 for every birdhouse I make. There's my objective equation. All right, now my constraints. So what you do for the word problem is you go back and you look at any limits that you see on materials or supplies or hours or time or possibly your land, or sometimes you just have some limits on how much you can output in a week or how much you need to output a week. And so I'm going to go back and I'm going to see if I can find any limits here. Each wind chime requires some work from Jean and Wesley. Each birdhouse requires 4 hours work from Jean, 2 hours from Wesley. Jean cannot work more than 48 hours per week. There's a limit. And I'll just write that limit as Jean. Okay. Wesley cannot work more than 20 hours per week. There's another limit. Limit in our hours with Wesley. You may have problems that are as simple as that with two limits. You may have some that get a little more complicated than that. All right, now I'm going to start making my constraints. My constraint inequalities. For each one of my constraints, I'm going to make an inequality. So I'm going to get Jean. Jean cannot work more than 48 hours per week. So her amount is 48. And Wesley only works 20 hours a week? Yeah, 20 hours per week, part-time. Okay. Then I got to go back and read very carefully about how much work it takes for each wind chime and birdhouse. Okay? Each wind chimes are X's, requires 3 hours of work from Jean. So I'm going to go to the Jean constraint line. The wind chimes are X's, and that's 3 for each wind chime. And 1 hour of work from Wesley. New line, not the Jean line. Now I'm on the Wesley line. For each wind chime, it takes 1 hour of work per week. Now I'll read on. Each birdhouse requires 4 hours of work from Jean. Birdhouses are Y. 4 hours from Jean would be 4 times Y. And 2 hours from Wesley. Birdhouses are Y's, so that's 2Y on the Wesley line. And when I add up what they're doing, and we'll always add on these, those hours have to be less than or equal to 48 and less than or equal to 20. Okay. Now I have everything that we had yesterday. So now let's try graphing. It's going to be easiest to graph with the x-intercepts and y-intercepts. We're only going to use the first quadrant, so we're only going to use the positive x's and the positive y's. So we don't have to worry about graphing down in the other quadrants, across or down in the other quadrants. And my x-intercept, to find my x-intercept for the Jean inequality, I make y 0. So 3x is equal to 48. My x-intercept is 48 divided by 3, which is 16. My y-intercept is make the x 0. My y-intercept, I solve 4y is equal to 48, which means I take 48 and divide it by 4 and get 12. And I'll figure out all my intercepts first, because then I'll scale my graph. Wesley, to find the x-intercept, take 20, divide it by 1, and get 20. For the y-intercept, 20 divided by 2, and get 10. So my x-axis needs to go up to 20. That's the highest number on my x-axis, on the x's. My y-axis needs to go up as high as 12. So I think I'll go by 2's on my x.